Okay, we're going to demonstrate how to enlarge an object. So here we have a simple object. It's a quadrilateral with corners A, B, C, and D. And what we're going to try and do is to enlarge that. Now you need to remember that for enlargements, you need two things. One, the scale factor in which you're going to enlarge by. So in other words, let's say you had a scale factor of 2, that would be twice as big. 5 would be 5 times as big, or perhaps half, it would be half as big. So that's the scale factor. And secondly, we're going to have a point around which we do the enlargement. It's called the point of enlargement. So I'm just going to place at the moment a point on the diagram to be our point of enlargement. And let's say, for argument's sake, it's here on this coordinate. Now the first thing that you need to do is to draw what are called perspective lines. And to do that, you simply take your sharp pencil and a rule, and you draw straight lines from the point of enlargement through to your corners. So we'll draw another one here. There we go. And there's another one from E to C. Oh, I missed that one. From E to C. And there's another one from the point of enlargement through this corner D. Now, as I move my point of enlargement around, you'll see that my perspective lines still go through those corners. Doesn't matter where I put my point of enlargement, even in the center of the shape, my perspective lines always are going through the corners. Let's put it back to roughly where it was before. I think that was somewhere like there. Okay, now let's say I want to enlarge that shape by a scale factor of 2. The important things to remember is a scale factor of 2 is a number bigger than 1, and any number bigger than 1 means that the enlargement would be in making the shape bigger as opposed to smaller. A number smaller than 1 will mean that the enlargement is shrinking. In other words, the image shape will be smaller than the original shape. Now, the first thing to notice is that our enlarged shape will still fit between those lines. And we want to enlarge by a scale factor of 2. So what we're going to do is just put this point on exactly on this coordinate, if I can. There. Let's look at the distances involved. All the distances will be doubled. So look at the distance from E to B. That is currently 2 units, E to B. And therefore, if we scale that by a factor of 2, that distance will double to 4. If I have a look at the distance from E to A, that's going along 2 units and up 2 units from E to A. So that means that 2 units along, 2 units up will be doubled to 4 units along and 4 units up. For example, look at E to D. That's currently 4 units to the right and 1 unit up. So it's going to double to 8 units along and 2 units up. So all of those distances are doubled. And also, the shape itself will have edges that are twice as big. So fortunately, I can use this program to nicely create my enlargement. So I go to my enlargement from a point to a shape. So I set my point, and I select my point of enlargement, and I want a scale factor of 2. And there we go, we get this shape now that is twice as big. I want you to notice that as I move my point of enlargement around, the shape that is being enlarged stays the same, but the actual enlarged shape is moving. As my point of enlargement gets further away from the shape, so does my image of my enlargement Notice that if I go inside the shape, then the enlargement is over the top of it, which is fine. Enlargement goes up here. Now, the important thing to notice, if I make this perhaps my point of enlargement there to make it simpler, look at C to D. That's got a vertical height of two squares, and which is actually a distance of 4 from 2 to 6, but 2 squares, and the corresponding enlarged line from C to D is C dash to D dashed, and that's 4 units long, twice as much. It doesn't matter where I put my point of enlargement, the distance from C dash to D dashed will be twice as big as it was before.